solving quadratic equations by graphing. Solving an equation like this with 3x plus 9 equals 0, which is not quadratic, right? That's linear. But solving it means find the value of x. And that's what we're going to do with quadratics. But we're going to look at graphing. And if we're going to solve this one by graphing, although you can easily solve it algebraically as well, but what you're going to do to solve it graphically is make sure you have a 0 on one side, which we do already, so we don't need to manipulate anything, and then replace the 0 with y to graph the related function. So the equation is 0 equals 3x plus 9. The related function is y equals 3x plus 9. And then graph that. And it's linear, right? It has a y-intercept of 9 and a slope of 3, so it looks like that one there. And you find the solution by looking at the x-intercept. So the x-intercept is at -3 and 0. -3 is the answer. So you can say x equals -3. Most of you would probably prefer to use an algebraic method to graphing, which is fine. I also prefer to use an algebraic method, but there are times when I'm going to want to use graphing to solve. So you need to know how. So let's have a look at this one we want to solve. This one you can't solve algebraically yet. We will look at 2 different algebraic methods, maybe even 3, for solving that. But as it is right now, you can't solve that algebraically. So we're going to solve it by graphing. The first step is to make the equation equal 0. And again, this one already does equal 0. Manipulate the equation to equal 0, and then you're going to graph the related function, and we're going to do that on your calculator, and I'm going to show you how. And then find the x-intercepts. Probably you can already do that on your calculator, but I'm going to show you anyway just to be sure. If it already equals 0, you don't have to change anything. You're going to graph the related function, and you do that by changing the 0 to a y. So you can graph that on your graphing calculator, and you end up with a graph that looks something like this. You find those x-intercepts, -3 and 2. So that means that for this equation, x is equal to -3 and x is equal to 2. Both of those values satisfy the equation. So if you fill -3 in for x in the original equation, it'll come out to a true statement 0 equals 0. If you fill 2 in, it'll do the same thing. They're both solutions. Here's another one that we need to solve. 2x squared plus x equals -2. What's different about this one? Yeah, there's no 0. So we need to do that first step where we manipulate it to come up with a 0. So all I'm going to do is add 2 to both sides of the equation so that I get 2x squared plus x plus 2 equals, and then it's -2 plus 2, so it's 0. Then I'll graph the related function, which is y equals 2x squared plus x plus 2. The only thing I'm doing in that step is replacing the 0 with a y so that I can find the zeros of the function. When you graph it, you find out that there are not any x-intercepts. So what does that mean in the context of this problem? Yeah, no solution. So that's what you're going to write for your answer. No solution. So there is no value of x that will satisfy that equation. this one already has 0 equals. So you're just going to go to your calculator, make that 0 a y, and you're going to graph y equals 100 plus 15x minus x squared. Go ahead and try to find those solutions. So graph it and then adjust your window or zoom out so that you can see both. When you first graph it, you're only going to see this one over here, the -5, because 20 is outside of your standard viewing window. But you can adjust so that you can see it. And those are the answers. If you're asked to solve by graphing, I made the 0 equal to y, I graphed it, there's my graph. What else do I need? I need x equals, right? If you don't state your answer, then you haven't solved by graphing. All I did right now is graph the related equation. To solve it by graphing, then I need to write it down. X equals -5 and x equals 20. There, now I solved by graphing. If you don't write down the answers, then you've graphed, but you haven't solved by graphing. Here's the next one. Try it on your own. Did your graph look like that?
Mine did, Dawn's didn't.
Mine didn't.
Huh. How many people's graphs look like that? It looks like maybe a little more than half. What did your graph look like?
Mine opened up.
Yours opened up?
Yeah.
It was the same but upside down.
But it probably had the same vertex, right? So either one is fine. What's causing the difference is some of you move the x squared over, and some of you move the 6x minus 9 over. So you could have graphed either of these. Let's see. Y equals x squared minus 6x plus 9, or y equals -x squared plus 6x minus 9, or some, like, they don't need to be in that order. You may have graphed something similar, but not in that order. And you get two different graphs, but what you find is they have the same x-intercept. So whichever one of these you graphed, you'll still end up with x equals 3. Okay? Give this a try.
Wait, how did we get 0? I'm just kidding.
You should all have the same graph for this one because
I don't know.
so it is. So this one was a little bit tricky. A little tricky because the two x-intercepts are so close together. And when you graph this one on your calculator, it looks like there's only one. You need to zoom in. You need to be careful when you think that there's only one x-intercept, that you make sure there is actually only one. Because this one, we have x equals -2.5 and x equals -2. When they're close together, sometimes it looks like there's only one. But remember, we looked, well, all those 6 questions that we did, or 5 questions, I guess, they all either had 2 solutions like this one does, or one solution when the vertex is the x-intercept, or no solutions, and that's when it doesn't cross the x-axis at all. Those are the 3 possibilities, 3 different types of answers you can get. 0, 1, or 2 solutions.